I think that means we're live. Come on in, have a seat. Welcome. Hello. Okay, no. I was looking for a welcome, but that was great. Boy, this has been a long time coming. We are just terribly excited to talk to you, meet with you today and tell you about Nano Server. I'm Jeffrey Snover. I'm a distinguished engineer. I'm also the lead architect for Windows Server and the System Center Data products. And with me?
I'm Andrew Mason. I'm a program manager in Windows Server.
And Andrew's been working on this project, really, how long has it been?
It's been 10 years.
10 years, 10 years in the making. This is a project that has taken sustained effort and perseverance. And it was worth the wait. Okay, so here we're going to talk to you about Nano Server. We're going to tell you, sort of what motivated this, what we've been hearing from customers. We'll talk to you about our server journey and our journey to the cloud. And then we'll talk about Nano Server, some of the details, what it is, give you some preliminary results, put an asterisk there. They are preliminary results. We have not done a performance pass on Nano Server, so we expect these numbers will get better, but they're pretty darn good. We'll also give you a status and roadmap and give you some call to actions, okay?
All right. So we've been hearing four main themes from all of our customers. 3 of them are covered in this slide. The next slide covers the 4th one. But the big thing is reboots impact my business. Why do I have to deploy patches for components that I'm not using on my servers? Why? And when a reboot is required, bring my machines back up as quickly as possible. So I want to get my systems.
Actually, we should check. Does anybody not mind reboots? No, I didn't see. Okay, you all passed the IQ test. You can stay. That's good.
Yes. And so when I do have to reboot, I want my machines back online as quickly as possible. So they're providing the services they're meant to be providing to my customers. And server images are too big. So it takes a long time to deploy a Windows Server. It takes a long time to configure it because there's so much in there. And that's great if you need all of that, but when you want to run a really fixed function server, that's additional overhead and configuration and management that you have to deal with that's not needed for that fixed function server. So along with that larger size, deploying it, especially if you're deploying in a large data center environment, copying those images over the network to all those nodes in your network, that takes a lot of network bandwidth, takes a lot of time. All those images take a lot of disk space. You also have the same amount of disk space consumed by your virtual machines, and there's stuff in those virtual machines that you're never using. So again, we want to try and make the images smaller. And then it requires too much infrastructure, or the infrastructure requires too many resources. So, there's all that great stuff loaded up, but you may not need it. It is consuming resources even if you aren't using it. So, eliminate those additional resource taxes that I have on my fixed function servers.
Yeah, there's a reason why whenever they show storage dedupe, they always do it against a VHD library, right? Because there's so much bloat in those images.
Right. And that also gives me higher VM density. So if my infrastructure OS is not requiring as much and I can build smaller virtual machines, I can run more of them on my servers that I have today. And then the 4th big bucket's all about security. We've all seen the headlines over the last year and a half, 2 years of all the security attacks that have happened. Having a lot of additional stuff installed on the machine gives those bad guys other avenues into your systems. So removing those is a good thing. And the second one from the bottom is an interesting one. Some of the attackers are even causing physical damage when they're attacking manufacturing plants now. So it's spreading beyond just stealing data and credit card numbers and things like that.
Yes, we've talked to some customers. Some people adopt this policy of a gold image where they put everything anyone might possibly want into that gold image, and then they install that on all their servers. If you're doing that, stop it. You're asking for a cyber punch in the face. Every component that you put on a server that isn't needed for the function of that particular server is an increased security attack service. So you want to stop doing that practice. I know a couple of you get nervous. It's okay, you got time, but stop it.
Okay, so what we're hearing is I want just the components I need and nothing more. So give me that fixed function server. Don't have a bunch of other functionality on there for management or other purposes if I'm not using it. Let me pick the pieces I want and deploy just those pieces.
Okay, so let's talk about our server journey. When we first started Windows Server, right, with Windows NT, we really didn't make a distinction between the client and the server. This was a world where I'd walk up to my server and I'd had a keyboard and a monitor, and the fact that I had a GUI there with a next button was just a wonderful world, right? In fact, the joke is that we just took a desktop and we kind of tipped it on its side, and that was a server. In fact, you might have heard of this guy, Mark Russinovich. Did I pronounce that right?
Yeah, I think so.
So Mark Russinovich was made famous, but he was the guy who discovered that the only difference between the client and the server was a registry key, and that if you changed it, you could turn a client into a server. And so then Microsoft changed the location of that, and he found it again, and it was cat and mouse before the guys at Microsoft finally sent him some mail, said, okay, we give up. Would you please stop doing this? So again, in that world, it was fine, right? You'd walk up to that machine and everything was great, gave you this nice, great experience. However, local admin GUIs on a server are poison. I mean that. They're really poison. It's like heroin. Your first shot's so nice, and then all of a sudden your life's ruined and you end up dead, okay?
Who would have thought you'd hear about heroin in a Nano server talk?
No, it's true. They're just horrible. And why, right? Because that first shot just feels so wonderful. How can you be saying such nasty things about that wonderful experience of mine? And the answer is this. Invariably, it's as though it were a law of physics. I don't understand why, but invariably, when you put a local admin GUI on a machine, the programmer writes their business logic and they put it in the GUI and then call private APIs. In other words, they don't have formal remoting APIs, which means you can't do formal management APIs, which means you can't do remote management and you can't do automation. Now, when it's a world where I walk up to the machine and I just have one machine, that's fine. You really can't tell the difference between that and a good experience, right? But when we shifted from that world and said, really, we're going to put the Windows Server in data centers, and then in clouds, where it's no longer about a machine, it's about dozens, hundreds, thousands, tens of thousands. In the case of Azure, nearly 1 million servers. This lack of management, lack of formal management is a disaster. It's death. So that's why we're very adamant against local admin GUIs. We love GUIs. Let me be clear. We love GUIs. Just keep them off the server. Have them on a client, and then use formal remote APIs so that you can manage it remotely, you can manage in mass, and you can manage through automation. So we really started our journey towards Nano Server in 2008, where we introduced Server Core. So Server Core was a small version of Server. It did not have all the GUIs. It had some of the GUIs, but not all of them. So you could still RDP into this box. But you picked one or the other, and you better get it right, because if you got it wrong, you had to clean slate the machine and start over. Now with Server Core, we also weren't very crisp about the scenarios we were going after. We basically said everything. And as such, it was difficult to be clear about, hey, I need you guys to do this. You guys, heads up, I'm coming to you next, and then I'll talk to you later. We couldn't do that. And so, in fact, in this time frame, 2008 and 2008 R2, the adoption of Server Core was not particularly good. Then came Server 2012. Server 2012, we fixed the management interface on Server Core, so we had full PowerShell remoting there. We didn't have that in 2008. It was something you could start off with Server Core and add a GUI, or start with a GUI and remove it and get to Server Core. And this was important because we found that a number of people in our ecosystem, products, required the GUI to do installation, but then didn't require it to actually run it. So that's how a lot of people are getting their Server Core systems running. They start with Server Core, get everything configured, and then bring it down to, or start with the GUI, and then bring it down to Server Core. Anyway, so that's how we've done things. Now we then shift gears to the cloud. And in the cloud, nobody likes patches. But in the cloud, patches are quite impactful. Okay, so Azure does not have live migration. So the ramification of not having live migration is that if and when I have to patch the host, every single customer VM has to be brought down and restarted. That is a huge impact, okay? So we have a compelling commercial interest in getting the reboots down. Next is, I mentioned to you that Azure has nearly 1 million servers. Now, 1 million servers times incremental resource usage, that translates into COGS, right? Cost of goods sold. There's another word for COGS, anybody know that? Profits. Profits. So again, we have a business interest in reducing the size of things so that we can deliver the same great service at lower costs. And then lastly, these very large images, when we have these very large VHDs, we're moving across the network. Again, that consumes a lot of network that we could otherwise be delivering to you as services. Now in Windows Server, we have something called Cloud Platform Solution. Cloud Platform Solution is our cloud in a box, right? Go to a website, say, give me a cloud, and you say 1, 2, 3, 4 racks, and you get a cloud in a box. Indeed, it's an integrated offering of hardware and software. Now, the joke of this is that prior to cloud in the box, we didn't have long setup times. You had long setup times, but we didn't, because when I was sitting in my office, I just installed one component, and it was fine. You know, I'd go grab a cup of coffee and talk to some people, and when I came back, it was fine. But with CPS, and all of a sudden, I had to set up 4 racks of machines. I had to set up a management system with a very large number of clusters, with a very large number of instances running highly available management software, all the System Center products. And when you put all that together, the setup times were enormous. And it really made us say, wait, that's what we're doing? That's horrible. We don't want to do that. And now the great thing about CPS is that we have live migration. Awesome. So if and when we have to patch the host, we don't have to have a service interruption. So that's good, right? However, let's do the math. I mentioned to you that CPS can have 8,000 VMs. Now, conservatively, let's just say we give them 2 gigabytes each. What that means is every time I have to patch the host, right? The way we do this, by the way, is we're going to patch a host. We first live migrate the workloads to another machine. We then patch that host, do the reboot, take those machines, move them back, and then move on to the next one. And you just do that through all the systems. So that's great. But when you have 8,000 VMs at roughly 2 gigabytes each, that means you're live migrating 16 terabytes of memory across a network that you're still trying to deliver services to customers. So whereas it might not have a service interruption, it does have a service impact. And of course, reboots are significant in this environment as well. So ultimately, what we concluded was that we needed a server configuration that was optimized for the cloud. Now, this is a literal statement. We need a server optimized for the cloud. I'm unambiguous on this point. I'm pretty sure you need one as well, but I know that we need one.
Yes. And so Nano Server is our next step in that cloud journey. So Nano Server is a new headless installation option for Windows Server. It is 64-bit only. And when I mean headless, it's unlike Server Core, which was sort of headless. It is completely headless. There is no local interface to it. There's no way to RDP into it and access the machine locally in any way, as we'll see in some of the demos. And it's a deep refactoring. So initially what we're focused on is sort of the cloud data center. So we'll get into that more, but it runs Hyper-V, scale-out file server, and clustering. We're working on bringing some more roles in. And so any feedback you have on additional roles you'd like to see on Nano Server, we'd love to hear that. And we're also focused on born in the cloud applications. And so that's Core CLR, ASP.NET V5, and many of the open source app frameworks that we'll see a demo of later. Yes. And we're following the Server Core pattern. So in Windows Server vNext, Nano Server will be a separate installation option. So you won't be able to move from Nano Server up to Server Core or down from Server Core. It will be a separate deploy time decision that you have to make. One of the things we've done with Nano Server, I don't know if you're familiar with Windows Server or even on Windows Client, when you install, you get a side-by-side folder laid down in your media. And in there are all the roles and features and optional things that you can turn on. So when you go turn something on, you never get prompted for media. That's because all those binaries are sitting out there in that side-by-side folder and get copied in and instantiated when you want to use them. Now, that consumes disk space, so all your VMs have copies of roles and features that you may not be needing. Well, with Nano Server, we separated all that. So Nano Server is a base OS package that will always stay the same. We're still making some adjustments to it. So like Jeffrey said, some of the numbers may change that we'll show later. But all the roles and features, so Hyper-V, clustering, storage server, and some other things that we'll see a little later on are all separate packages. You have to add them when you decide to deploy the system for the role you want that server to play. If you decide not to use clustering, you never have to have those clustering binaries in your image. So the key roles and features, like I mentioned, that we're focused on are Hyper-V, scale-out file server, and clustering, and then Core CLR, ASP.NET 5, and PaaS. Now, it does have full Windows Server driver support. So if you have a driver for a piece of hardware that's supported by Windows Server, you can use that same driver and run Nano Server on that hardware. No special hardware required. It runs on all the same systems. It does have anti-malware built in, so just like the rest of the Windows Server installation options in vNext, Defender is built in and on by default in Nano Server, so you have antivirus protection out of the box. And we are working on moving the System Center agents over and Apps Insights and all the other agents that Microsoft produces, make those available on top of Nano Server. And we've reached out to a lot of the ISVs and have a lot of them engaged as well already to start moving their agents to work in the Nano Server environment. So let's go ahead and try our first demo here.
Hey, now can you see this? You see this? This is a Hyper-V cluster.
That's a Nano Hyper-V cluster.
A Nano Hyper-V cluster. If you can't see it from the back there.
I think you need,
huh?
You need to wake up now.
Oh, gotta wake up. That's what you see right here, okay?
The bottom machine is running Windows with the local admin tool, so it has Active Directory DNS and DHCP on it, and then the top two machines are Nano Server. And the switch at the bottom is what everything's connected into.
Yeah, the switch is much larger than the Hyper-V cluster.
Yes. Yes. And the switch also takes a lot longer to start up than the Hyper-V cluster.
We had a problem with this. We set this up, and we're like, what's wrong? What's wrong? And the answer is the Nano servers just started up like that. Well, the switch was still like, oh,
right. I'm trying to figure out why I couldn't connect on the network. Well, there was no network yet. So let me wake this one up. Caps lock, thank you.
It takes a village. Together, we will get this thing shipped.
So let me reposition a few things here. So you can see I have in Hyper-V, I have my two nodes, and I have VMs running on each one. So I actually have my Nano Server VM and a server with local admin tools build installed here. And then on the other node, I actually have a VM I'm going to use in a later demo.
So what you're seeing, by the way, is Hyper-V Manager
remotely managed.
Just working.
Yes.
Just works.
And
no
here's
drama.
Failover Cluster Manager doing the same thing. I'm connected up to my top two machines here. I have my roles running on those, so you can see the two machines I set up for high availability. So I'm going to switch over to...
Behold the power of remote management.
Yes. Power of remote management. And you can see Server Manager sees those machines as well. So Server Manager can connect up and manage them as well. I'm going to switch over to PowerShell here, and I'm going to run Git sim instance.
Makes me feel all warm and fuzzy.
Because I can't actually connect to any, I can't show you the local UI because there is none. So you'll see I've got the three machines, 01, 02, and 03. 03 is the bottom one running Active Directory, so that's the one I'm actually showing on the screen. You can see the other two have Tuva in the branding string. Tuva was our internal code name for Nano Server, and so we have a slight fix we need to make there, but ignore that, it makes it easy for the demo. And then I can also run my Git cluster resource. And you can see what I was showing earlier. Actually, how do I flip these around? There, I can move it up. So you can see I have my IP address, my cluster names up and running, and the two virtual machines that I showed running on my cluster. And so now what I will do is I will let's go ahead and VM connect to this. Oops,
connect into the Nano server?
Yes. It's not going to show much, but I wanted to show it move in the background, but that's okay.
I see.
So what I will do is I will now live migrate this and hope it all works. There we go. You can see it's a very exciting UI. black screen and a little cursor. That's all you get locally. So now, here we go.
Someone at the booth wanted us to change it and have it show a display of a bitmap saying, you can't do that.
That would be pretty funny. All right, so now we've got the connection going, and we can select node, and I will...
Now, don't blink.
That's right. So you'll be able to see at the bottom in the failover cluster manager, it's actually going to come up faster there than the VM Connect window, but you'll see it start failing over. Or live
So again, we've got Nano server running hypervisor, running some VMs, which are Nano server VMs, and we're doing live migration from one to another using the GUI tools.
You see in failover cluster manager, it's already up and running again. VM Connect still trying to connect to it. As we saw, that was a little slow connecting for whatever reason this morning. Not enough coffee.
It's good.
Yes. So that's pretty cool. So now I've got
you like that. I like that.
I've got another machine here that basically has a Nano server VHD on it with an unattend file in it. It is not joined to the cluster as we saw. I only have 2 machines. It's not even joined to the domain yet. And so now I am going to plug this in and add it to the cluster.
Are you as nervous as I am?
I think I'm the most nervous one here. So we will turn that on. All right, let me minimize this, and then I will go over here to my other demo script that I forgot to open. So let me... So we'll start out by setting up a new...
Not carriage, turn F8.
Yes, return F8. Where's the undo button?
Control Z.
I can't see on this screen. It's demos. I always forget what to do. Okay, so I will log in. I'll set up a new PS session, and then I'll enter PS session to it. All right, so you can see the machine's already up. I connected over the network. So here I am remoted into it using PowerShell, and I hit enter again, didn't I?
Yep.
So I'm going to run a WMIC command, which you can run locally once you're remoted into your Nano server machines. And so it is still in the work group. Now I've already copied the domain join blob over, so you can do offline domain join with Nano server. So,
by the way, I think by the way, how many people here know PowerShell? Oh, good, good. So if you don't, what's here, we're running local GUI, we're running PowerShell, we've connected over PowerShell remoting, and now we're running things, we're gonna join the domain.
Right, so you can see my Nano GB05 VHD, that's what I booted from, 430 megabytes. There's my domain join blob that I created earlier on my domain controller and copied over. And now I'm gonna go ahead and actually join the domain. So there's a djoin command that you can use both to create the blob and then to apply it. And you'll see it's finished and told me I need to reboot now.
But it requires a reboot.
It does require a reboot. You can actually do this.
This is going to take a long time.
No, it's not. But you can do this in your unattend file. You can include this in unattend, and we've also moved some of the common configuration settings into an offline phase of the unattend file. So you can set your computer name, you can set your admin password, you can do your domain join all offline. So on first boot, it all gets provisioned, and you come up, and your server's up and running. There's no second reboot like you get with Sysprep.
But you keep talking. Doesn't a reboot take minutes?
Reboot does not take minutes. Not with Nano server. So here, I'm going to shut it down and have it reboot. Let me exit my PowerShell session here. So I did delay it by 2 seconds, and the boot manager does have a 3-second delay on it. So it will be here pretty quickly. And so I'm going to run sim instance again, and now I'm also going to include the Nano GB05 machine. And yeah, it's not up yet. All right. Maybe you should have been nervous. It was just up. Let's see.
The demo gods.
The demo gods have frowned on me today, yes. Oh, actually. Wrong window.
There you go.
It's up. So it's back up. Let's try. We'll just go ahead and enable CRED SSP on it. All right, it's happy about it now. We'll go back to sim session in a minute. So I enabled CRED SSP so I can pass my credentials over the network. Then I have my VMs actually stored on a share on my full server machine here. And so I'm going to do SMB delegation so I can access that share. You can see it's loading the commandlets. Why did it? Oh, it looks like it did not join the domain successfully for some reason. That's my problem.
Okay.
All right. Well, the next thing I was going to do was add it to the cluster, which probably won't work either. And then the longest part of this whole process when it is working is actually creating the new network switch, the virtual switch, and joining that up with the rest of the nodes. That's the longest piece of the process.
Now, the good news is shortly after this session, we will we have video demos of all of these, and we'll be loading them up on Channel 9, so you can see it working there.
Yes. Well, the live migration worked and the 2-node worked.
It did.
And the fast boot worked, but okay.
Okay. All right.
It's still an early build.
Yeah, it's worth noting. We are very early days with Nano servers, and so it's now available?
It is available. So technical preview 2 that was posted Monday morning, if you download the ISO, there's a folder called Nano server within the ISO where you can get the Nano server WIM and a link off to the deployment guide on TechNet. And we'll talk more about how you can work with that a little later in the slides.
And the thing to remember is it boots faster than your switch, so.
Yes.
All right, so let's talk about the management. We are going to eliminate the need to ever walk up to a machine and have to manage it, right? That's the goal. So we're going to do desired state configuration. You configure you configure both Nano server and things on Nano server using PowerShell desired state configuration. You'll do remote management, operations, automation with core PowerShell and WMI. So, you want to integrate into DevOps tool chains. So again, if you're not familiar with the DevOps effort, I encourage you to get involved in the DevOps community. It's basically kind of a philosophy of doing management en masse and improve the quality of your management, IT operations, and really drive business value. There's a great community, and there's a different approach to managing things. They've got this great phrase. They say, you want to manage your servers like cattle, not like pets, right? Pets, sometimes they call them snowflake servers, but with pets, you give them names and you take care of them and you worry them about them and you fuss over them. And when they get sick, you take them to the vet. You don't do that with cattle, right? With cattle, you give them numbers, not names. And when something goes wrong, you fire up the barbecue. It's a different mindset completely. And that's the way you want to be with servers, You want to set up automated operations, and then if something goes wrong, just, repair it, reboot it, or replace it. No drama. It's all about eliminating the drama and the heroism from IT. Okay? Now, there's a number of DevOps tools. Encourage you to take a look into them. But basically, what we're going to do is we're going to ensure that we've got all the manageability so that Nano server works well in a DevOps tool chain. Now, tomorrow, please make a note of this. Tomorrow at 1:30, Dan Harmon and I will be going into the details of how you remotely manage Nano server in room S105D. Okay, so now notice I said you manage it with core PowerShell, not PowerShell. PowerShell requires .NET, the full .NET. The full .NET is not installable on Nano server because it's too large, has lots of APIs that use the GUI, etc., the GUI stack. On Nano server, we have core CLR, and therefore we have core PowerShell. Now, I'll tell you that core PowerShell is not its final name. That's just a kind of holder name. We'll come up with a better name shortly. This is a version of PowerShell that's refactored to run on the core CLR. It has full language compatibility. including remoting. And it has most of the engine components. The one significant engine component that it does not have is workflow, PowerShell workflow. That's not really a problem because PowerShell workflow, as you know, I can run the workflow on this machine and then manage all these machines through the magic of PowerShell remoting. So you do not need PowerShell workflow to be running on a machine for it to participate in a PowerShell workflow. And it supports all your types of PowerShell commandlets, so .NET commandlets, C#, script commandlets, and sim commandlets. The one caveat here is that if you have commandlets written in .NET, those have to work on the core CLR. And if those commandlets work on the core CLR, they're going to run just fine in full PowerShell and the full CLR, but not necessarily the other way around. So that's something you'll have to check. And we're really starting off with a limited set of commandlets. Honestly, this was a project that required, again, a huge amount of work. These refactoring efforts are some of the hardest engineering things you do because you're dealing with such a very large volume of stuff. So it took us a very long time to get to Hello. A few weeks later, we got Hello World. And at that time, we had, I think, 150 some odd commandlets. You might have seen a video of that. Since then, a couple weeks after that, we got to 300, and I think now we're up to 600. So it's an area where what you get next week or this week, you'll see that it's pretty limited. It's growing rapidly. So let's show you some core PowerShell. All right. Okay, so I've already got a connection to this machine, $NS, Nano server. I've already got a connection. And what I'll do is I'll create a connection to it. Okay, so now I'm logged in locally. I'll go ahead and change my prompt. Then just show you that the language works. So 2 + 2 is 4. Can you check my math on that?
I think that's right.
Okay, so fidelity so far. Here we'll have a for loop. So again, all the language constructs. So for I = 0, I less than 5, right? PowerShell rocks. Ta-da.
Nano server rocks.
Yeah, Nano server rocks. Yeah, sort of both.
It says Nano server. There we go.
It's the power of scripting. You can do anything. Okay, so functions work. So here I'm going to write myself a hello world function. And there you go, hello world. And notice when I try and convert that function to a workflow, it'll come back and it'll say workflow is not supported on one core PowerShell. Now you see that one core, here's what's going on. So PowerShell, as you know, we've refactored the kernel so that everything, all of the various things, Xbox, the phone, the client, the server, are all using common code, building out of a common tree. That base component, including IoT, that base component is called one core. And so when we did our refactoring work of PowerShell, we didn't target Nano server, we targeted one core. What that means is that any of the SKUs can run PowerShell on it should they choose to. And in particular, a number of the phone and the IoT guys use PowerShell as part of their development process. All their tests, all their developers use PowerShell for that. And so we refactored it to run on that. So that's why it doesn't say Nano server. So next, what I'll do is I'll show you a list of the modules, right? So limited set of modules, but pretty good. You see, you got all the networking, you got SMB, you got the storage. We even have PnP devices. So we're using PowerShell to clean up our management. A lot of times there were things that's like, yeah, we should do that, but well, there's another way to do it. Now, there is no other way to do it, so we have to go back and ensure that we have full, complete remote manageability of every aspect of the system. So we have a new set of PnP commandlets. So here, do CLS, show you all the commands. And you'll see pretty good list of stuff, yeah? Pretty good. Yeah.
Come a long way since January.
Yeah, this has come a long way. Okay, so just to be clear, we'll measure that. And we got, as of today, we got 628 commandlets. Okay, that's good. Now notice here that with Nano Server, still everything you expect continues to work. So get dash, okay, IntelliSense works. Process, dash name, watch here. Now look here, it shows you IntelliSense for the names on the remote Nano Server. And look how small that list is. That's because there aren't many processes on Nano Server. That's a good thing. Yeah. Okay, so where, Dollar underbar, dot, look there, the names continue to work. IntelliSense, greater than, say 10 megabytes. Sort, working set, format table, name, working set. Now notice, I'm not gonna, anybody use PowerShell? Yeah. So you know how you'd like do format table, and you always have to say minus auto size, because otherwise things are all horrible. Notice, I didn't say auto size, right? Or if I add, ID, right? Just, so now auto size in formatting a table is automatically done for you. And the way we do that is we take a particular time and we take a particular number, and we'll auto format based upon those initial offerings. So very cool, big addition. Of course, we got network adapters, PowerShell drives, all your namespaces are here. So here's the certificate store, all your certs, your environmental variables, the registry, and now check this out. So notice here, I do a dir of the modules. I don't have any modules on this thing yet. Well, that's not good. So now I exit. Exiting takes me out of my session of Nano Server and brings me back to my client. So now what I'll do is I'm gonna say copy. So on the local client, I've got a module, history PX, and notice we have this new parameter, -2 session. So I'm gonna copy to this session from this location. Okay, now I'll go back, connect to that remote machine, and run that dir again, and there's that module. So now we have file transfer over PowerShell remoting, both directions. So here, we'll take a look. We got DISM logs. Well, that's great. So I'll come back to my local context. Here, we'll do from session. And so I'm going to grab the logs from the Nano server, and I'm going to bring them back locally, and then party on. Anyway, so great stuff. And then there are my logs. So I can just party on. So we're using PowerShell and core PowerShell on Nano server to drive and have great remote manageability. Now here's the point. A lot of people will hear us, we talk about the cloud, and they'll say, well, hey, that's great. I understand why you're doing that, but I'm not there yet. I'm an enterprise guy, and I plan to stay an enterprise guy, and maybe I'll look at that cloud later. Well, here's the story. The vast majority, not 100%, but the vast majority of the things that we do to improve the world of the cloud will improve the lives of the enterprise. All the work we do to improve the manageability, the PNP device, the transfer, et cetera, are available to you if you want to continue with the enterprise scenarios. So it's all goodness. Hello?
You broke it.
Wonderful. Well, I'm going to talk to you, if somebody could help us. So next, what we're going to talk, why don't you talk to them about reserve?
They'll be back in 1 second.
Okay. Now, if this was running Nano server, it'd be back even sooner.
Faster, yes.
So next, we're going to talk to you about remote management tools. Now, again, it falls directly in line with what I was just saying. In the past, we've had manageability tools that we could run on a client and manage a remote server. but honestly, it was spotty. Some things did well, we had coverage for some things, but not other things. Device manager, couldn't do device manager. If you could, there were operations that you couldn't do. Additionally, there were some tools that worked remotely, but honestly, they weren't all that good, like the remote event logging. And so what you're going to see is, one, we're investing in those tools to make sure that both the tools and the manageability themselves, so that we have full first-class experience of remote management using GUIs.
Yes, and that's sort of, I don't think you mentioned it, but also because we've heard a lot of feedback with Server Core that there are things that you still have to RDP into Server Core to do. There's no remote equivalent of them.
Yes, exactly.
And so we're doing a bunch of work to, thank you.
Yeah, give it up for the AV guys. Thank you very much.
So these are a bunch of web-based tools. So the great thing about these is you can run them from anywhere. So you could even run these, if you're out to dinner, use your phone to connect up and manage your servers. You don't have to RDP in from your phone. And basically, these include replacements for a bunch of the local-only tools that you have to RDP into Nano or Server Core for today, because obviously, as you saw from Nano Server, there's no way to do that. And so everything above the dash line we have working today, and I'll show off in our demo. The things below the dash line are all stuff we're working on. So like Jeffrey said, there are some tools that do work remotely, but the performance isn't always so great. So we're looking at replacing those and keep adding tools to this. And the great thing about these is they'll also manage Server Core and your server with the local admin tools remotely. And so one of the things we're doing to make these work, to Jeffrey's earlier point about business logic and calling private APIs, this all calls WMI and PowerShell remotely. So anything these can do, you can do via scripting and automation, or you could write your own UI to layer on top of it, or tie it into your own custom tools you may have. So we're going to do another demo. And hope the AV switches. All right. So this is actually running in the other virtual machine I have running that I have not clustered. And so here I am connected up in my web browser. If I go to home, this is the Azure portal, the new version that's coming. And I've already created a connection to my Nano server machine. So 192.168.100.12 is actually number 2 in my stack here. So I'm connected up to that. And I can open that up. And you can see it gives me, basically at the top, the core view of what that machine is. So it shows me its computer name, it shows me what it's running, it shows me its IP address, and it shows me the username I've connected up with. And so if I click all settings here, you'll see a bunch of the things that are very control panel-like show up. So I get this general one. This lets me see operating system, and you can see if I hover over it, it should give me the tooltip and show it's Tuva. So I am connected up to number 2 here. It is a gigabyte machine. It tells me what processor it is, how much RAM it has. Under computer identification, and go change the computer name. I can move it into a work group or join a different domain. I can put in the credentials for that new domain here. I can create new user accounts remotely from this. I can go look at my networking on here. So this has a network adapter in it. And then if I double click on that, I can go in and I can change from dynamic to static IP address and do all my network management here.
Including clear DNS servers?
Including clear DNS servers, yes. Oops, didn't want to go all the way back, oops. Then coming are updates and refresh settings. So if you click on updates now, it's just going to say coming soon. But we are working on that, so we'll have more capabilities to continue to add much of the control panel type settings information in here. So you can do that all remotely. And one of the things you'll see when you first open it up, at the top here, it does give you the ability to restart your machine or shut down. So you can just go in this tool. And then as I go down here, you'll see I get my performance information. So I get a view of the performance on the system. So I can go look at my CPU performance and drill into it. See, I have it's a 2-core, 4 logical processors, so I can get the details on that. I get the processes and threads. I can go my network adapters again, and I can drill down into it, much like I did through the Essentials option. I can look at the memory load on the system,
Nice.
do the page pool, non-page pool. So a lot of the things you can get in Task Manager are all available through this now. And this one here is, you can see their disk performance as well. By default, disk metrics are turned off, but I can just go in here and click Enable, tell it yes, and now it's going to load that, and there we go. And this machine happens to have one disk in it, but would show you all your disks, and then you can drill in and look at the performance on each of them, look at the response time. Lots of detailed settings there. And then further down, we have started moving some of the MMC tools over. So here's the processes view. So this is all the processes running on my Nano server machine, and I can actually, where's VMMS? Where'd my mouse go? Oh, it's, all right, well, my mouse decided to die. I'm just not having luck with demos today, am I?
There we go.
Well, I can
Using the amazing keyboard.
I can use the keyboard. Keyboard still works.
I never trusted those damn things, those damn mice anyway.
Damn mice. But if my mouse was working, I could right-click on these, and you can end process and create process dumps from them. And maybe we should move on, and we'll come back to this.
Oh, no,
I'll show the other tools.
Can you show can you use the tab?
All tabs can, yeah, perhaps.
Watch this. Use the amazing keyboard.
Yes.
There. All right, man of the hour.
All right.
Okay, give it a try. Well, you do that.
See, this is why you want to use PowerShell.
It is.
It just types. You don't need a mouse.
Exactly. That's the real demonstration. It was a hoax, you see. Well, what we see here is that in the middle there, you see PowerShell. Okay, and so you can connect to a PowerShell session, and the neat thing is you have a full PowerShell command line in the browser. And you've seen that for a while. Oh, okay.
So I can right-click, I can end process, I can create process dump. Thank you.
Thank you.
I can go into services, and I get the same view, and I can do my standard things, like if I right-click on it, I can stop and start services, I can pause services, I can resume services. We'll get to your PowerShell, don't worry.
No, that's fine. Show them the registry. The registry
editor. Yes, the registry editor in a browser. So I can expand out and navigate down the registry. And you'll notice I have these filter boxes at the top. So at any level, as I drill in, I can filter for what I'm searching for in the registry.
You can now screw up your servers using any device you like.
That's right. So there's the registry running in a browser. Now if I go back, roles and features. So this is just a view of them right now. We are working on adding the ability to add and remove things remotely through this as well. And so you can see this particular Nano server machine, I do have failover clustering like I showed. I have Hyper-V installed. I do have file server installed on there. The role administration tools that are showing up there, that's a bug in the system right now that we have to fix. Those aren't actually there. And then PowerShell, Jeffrey's favorite one. So here we go with PowerShell. Here's giving me a remote PowerShell session into that machine. And there I am connected. And one of the great things is I can click on commands here, and it shows me all the modules I have loaded.
And so you have, and you have show command in the window. So wait, you got to show command.
I am? What? Yeah, wait.
What?
This is an early build. This isn't even available. This isn't available in technical preview yet. Oh, it's still out there.
Yeah.
Sorry, my screen's too small.
It's
still out there. So I can do get, or here, let's do set. Set, execution.
You just select it now. It's right there, you just select it.
It came up. And there it is. Sorry. Having a hard time reading this monitor.
Oh, I see. Here, let me show you something. Get out of the way. Here.
All right, he'll do the demo from now on.
Oh, where'd it go?
See, now you did it.
What? What was that?
What did you do?
I don't know. You might have guessed that GUIs and I don't have a
No, they don't.
comfortable relationship.
You have to click the little,
Oh, there we go. Okay.
like that.
Say, there we
There
go.
we go.
So process. Right, so then get process. Star SS. Then you run it. Voila. Okay, so, GUI from the command line from the GUI. It's a beautiful
right.
thing.
Yes, and it's
Dogs and cats living in harmony.
and this will update here based on what parameters are available for the commandlet that you've selected. So that's pretty slick. And we can go back over here,
Yeah, I got to show them Device Manager.
Device Manager. Yes, I have unsaved edits, that's fine.
Never seen this before. Device Manager in a browser.
Device Manager in a browser, here we go. I can expand out my network adapters. I can go look at my actual physical NIC. I can expand that out. I can see what drivers installed, the date and the version of it.
A little earlier, you would have seen a big red dot next to the mouse.
Yes. And then we can go into Event Viewer. And I can do the same thing I was doing with the registry. I can drill down through Event Viewer at all my events. And again, at the top, I have the ability to filter. So I guess I don't have anything in my security log. I guess that's a good thing.
That's a good thing.
That is a good thing. So my system log, you can see a bunch of events in here. You can actually expand these out and get the details on the event and the description. So you have full remote event viewer, very snappy, much faster than using event viewer MMC today. So we're adding more tools, and like I said, this will work against server core and full server as well.
Hey,
Well, don't break that. So earlier we talked about Nano Server as your host OS. Nano Server can also be your cloud application platform. So what we're focused on here are born in the cloud applications, so Core CLR, ASP.NET, and many of the open source app frameworks. We have a list of those that actually are running on Nano Server today coming up in a few slides after Jeffrey does another demo. Now, Nano Server is going to be available everywhere. So you can use it as your host OS on your physical machines. You can use it as a guest OS on your virtual machines. And coming will be Nano Server as your base OS package for both Windows Server containers as well as Hyper-V containers. So you can use it for any of the places you can install a Windows operating system. And we are working on adding desired state configuration, package management, which used to be called OneGet. So that will all be available on Nano Server. So you can use that to deploy, configure, pull down additional functionality that you might need on a Nano Server. And like I mentioned earlier, we are looking for feedback and additional roles. Lots of people have been coming by the booth in the expo hall, so we're collecting some great data. So please feel free to let us know what else you would like to see running on Nano Server.
great. So let's talk about server application development, because as we talk about containers and we talk about Nano Server, sometimes the story gets a little bit confused. It's actually extraordinarily simple. So here's what we're doing. We're doing a dramatic refactoring of the server. Okay, at the bottom is Nano Server. This is Windows Server. It is just a subset of the other instances of Windows Server. So it's full API compatible for the functions that exist on it. It is Windows Server. Then there's something we call server. This is what we used to call server core. We're not going to call it server core anymore. We're going to call it server, because guess what? That's what it is. It's the server. No qualifications. It's the server. Now then we had this component on top of that we had some names for in the past, right? We used to call it full server. That sounded good. That wasn't what we intended to do. So lately we've been calling it server with a GUI. In the future, Confucius once said that the first step to enlightenment was calling things by their true name. So we're going to take the first step to enlightenment going forward. We're going to call this thing the client, or the client experience, because that's what it is. It is the client components. It is the client stack. It is the GUI stack. It is Shell, Explorer, IE. Okay? Now, why would you ever want to put a client stack on top of a server stack? And the answer is, there's very good reason for it. Remote desktop. That's exactly what remote desktop is, right? The ability for multiple people to have a client experience from a server. And whenever you need local GUI tools like Small Business Server or Small Business Essentials, where literally those guys still buy a server, it's their server, they walk up to it, they give it a big hug, and that's it. They want to have local GUIs for that, so that's fine as well. This client stack is for RDS. It is not for server application developers, okay? So server application developers are going to target server or Nano server. So literally you'll get into Visual Studio and you'll say, I'd like to target Nano server. It'll come up, you start typing, IntelliSense will show you only the APIs available in Nano server. If you bring in some code, some old code, it will go, and if you're using an API that's not available in Nano server, you get squiggle brackets, okay? So you're targeting server or Nano server, and then you produce your exe and you deploy it somewhere. How do you deploy it? Well, you deploy it on a physical machine, a virtual machine, or in a container. So that's right. On a physical machine, you deploy Nano server or server. In a VM, you deploy Nano server or server. In a container, you deploy Nano server or server. Any application that runs on Nano server will run just fine on server.
Well, I think something to point out there is the client piece of server will not be available in containers.
Exactly. So we're being hardcore about that. The client APIs, Shell, Explorer, IE, these will never be in containers.
And Jeffrey already stole some of the things on this slide. Ooh. You got ahead of us. The Windows SDK that's coming out when client ships, we'll talk about Nano server. There's a section in there in the server content about Nano server. There's also a Visual Studio 2015 template for Nano server that you can download from the gallery. And that will let you in Visual Studio, like Jeffrey said, target Nano server and see what APIs are available and what will work. Gives you that full design time experience, the arrow squiggles if you use an API that's not available in Nano server. It also lets you do remote debugging. And we do have a video of this all working up on Channel 9. If you go to Channel 9 and search on Nano server, we have a whole list of videos, and we'll have more coming. Now, there's also this new technology in Nano server called reverse forwarders. As part of the deep refactoring to create Nano server, we had to move some APIs that are commonly used by server code that exist in higher level DLLs, like shell DLLs, for accessing things like the registry and file system. Those got moved down into new DLLs. And so if you run an application that's linked to one of those DLLs, it's going to fail on Nano server. However, what we've done is create reverse forwarders, which basically are little stubs of those DLLs that allow you to an application to start up. If it calls an API that's in Nano server, it will find that and be able to run on the system because it gets rerouted to the new location. And so this allows you to start getting some things running without having to recompile and retarget for Nano server. And the great thing, even if you do retarget for Nano server, those same apps and code will run on server and server with client. Now, it does not eliminate the need to refactor code to run on Nano server. So if you are using an API that's not in Nano server, the reverse forwarders aren't going to help you with that. But a lot of the open source app frameworks and other tools that we've been trying just run fine with the reverse forwarders on Nano server. So this is an optional package. Like I was saying earlier, Nano server will have a base, and then you can build it up with the pieces you need. So if you're going to run something that maybe requires one of these APIs, you can install the reverse forwarder package. But if you're creating a very locked down Hyper-V host, you don't need to install this as part of your Nano server deployment. And so the list of available reverse forwarders is here. You can see some of the higher level shell binaries, kernel 32, the common dialog box, and common controls. There were APIs scattered about in Windows.
Great. So let's talk about what runs with reverse forwarders today. I mentioned to you that we are focused in on born in the cloud applications. So here's the mindset. Anything somebody's writing a cloud application in, any language, any runtime, that's what we're getting running on Nano server, and we're making fantastic progress. Okay, so we've got Chef. DevOps tool chain. That required Ruby. So we got Ruby, PHP, Nginx, Python, Node.js, Go, Redis, MySQL, OpenSSL, Java, Ruby, SQLite. Anything people are writing web cloud applications in, we're going to get running on Nano Server. So if there's something there that's really you're passionate about, let us know. Most of the things I think of are there. You know, the two are Erlang and Scala. I don't know anybody using those, but anyway, if you're using them, come talk to me, because I don't have plans for them. But we'll eventually get them. Now, let's talk about Chef. Okay, so we reached out to our great partners at Chef and said, hey, we got this cool thing, Nano Server. Can you help us?
They're down over here waving at you.
And there you go, Adam Edwards, superstar Adam from Chef. Give it up. You probably should have waited till after the demo, but anyway, it was well deserved. Anyway, so we're going to show you Chef running on Nano Server. We work closely with them. Turns out that we're running 32-bit, so we had to get them on 64-bit, and so we got a 64-bit version of Ruby. It's running great. Can you read that?
Yep.
I don't think you can read that. Let's make that a bit bigger. Okay, so now I'm connected into my Nano Server. I'm going to do, okay, so this before, get process. Look how small it is. Very few things in there. Nice small Nano Server. So a CD into now Chef 64. Okay, I'm going to run the Chef client. Now, what this is doing is running a Chef recipe to deploy and configure Nginx and a Django framework. So Chef is Ruby. Nginx is C, and Django is Python,
Yes.
all running on Nano Server. And literally what it's doing at this point, it didn't work earlier this morning from my hotel, because it's actually reaching out to the network to pull down all the components from the network to install them on Nano Server. And this point takes a little bit, if it will work. Okay, take back all your applause from Adam. Adam, this. No, it's a networking problem. It worked in the speaker room, but didn't work there. It's a networking problem. It's trying to reach out and grab those packages, and it's not finding them. But we got a video of that up on the website. It's working very well. Again, great partnership with Chef, so to ensure that Nano Server fits into a seamless DevOps continuous deployment workflow.
And as part of that partnership, we did find some things that we added to the reverse forwarders. So as people are finding code, trying to run things on Nano Server, we're continuing to enhance it. We still have time before we release. We're going to make it better and better.
Exactly. Now, I mentioned to you that a number of these videos are up on Channel 9. If you just search Channel 9 and Nano Server, you'll see that the Nano Server team has its own channel. And these are a bunch of the videos that we did. Oh, do we have them all here? From last week's build. And then later on today, we'll have a bunch more from this session. Let me just check one more thing. Did it work? Oh, Intel error. That doesn't look good. I'm just going to try it just in case. Nope. Yeah, okay. You do the honors, my friend.
Okay. So we've been talking about some cool stuff and said a lot of things about how great and small it is and how fast it is. Let's look at some of the results we have so far. And as Jeffrey mentioned earlier, still early, we're still making changes. Some of these numbers may change. And as we make improvements to Nano Server, we're also trying to make equivalent improvements, if it's something that's slowing the whole system down, up into server core and server. So, servicing improvements, what everybody really cares about here. We want to get rid of all those reboots and all those patches we have to apply that cause those reboots. So looking at all the security bulletins released in 2014, Nano Server would have only had 9 important bulletins compared to 23 and 26 for full server. The critical bulletins, 2 for the entire year. Server core would have had
1/10 the number of critical bulletins. That's crazy.
And then the number of reboots, we would have had 3 all year, server core 6, full server 11. We're doing some things. We want to get that down to a maximum of 2 per year. So reboot every 6 months. Security improvements, we're still doing some work here, so the number of drivers is still fairly comparable, 73 to 98. Services running, we've got about half, a little less than half, 22 to 46. As you saw from the list of processes that Jeffrey ran, we've got a lot less there. Ports open, almost a third less, so 12 versus 31. So again, reducing what those bad guys out there can try and get into your system with. And these numbers here are all against server core, so you can imagine server with the client on it is going to be even higher. So on the resource utilization side, process count 21 versus 26. This is an area we're just starting to work on. Boot I/O, 150 megabytes versus 255. This is one of the reasons, being so small, it can boot up so fast. Kernel memory in use, 61 megabytes versus 139. So again, more resources available to do other things on your servers. And then the deployment improvements. This is where it gets really fun. So setup time for Nano Server, 40 seconds. Server core, 5 minutes. And that is fully specialized with computer name, IP address on the network, ready to go. You can do that all via your unattend file. Like I mentioned earlier, you don't have to get that second reboot because you can put things in the offline section. It's also much faster to Pixie boot. We should have a Pixie boot demo that I think posted on Channel 9, but we used a couple old tower machines in our offices with a 100 megabit switch, and we could Pixie boot fully deployed Nano Server in a little over 3 minutes. Same setup with server core took 19 minutes. So quite an improvement. And a lot of that time on the Nano Server side was spent with WinPE, so we'll have to see what we can do there.
Yeah.
Then the disk footprint, 400 megabytes compared to almost 5 gigabytes. Much, much smaller. Oops. On the VHD, there's a little bit of overhead, but you can see it pops Nano Server up by 10 megabytes versus a couple gigabytes for server core.
Yeah, and I think full server's about 8 gigabytes, so it's almost 20 times smaller. 20 times smaller. So I like to say that, yeah, you like that? I like to say that, you know, when you go back home and you're going to encounter people who say, well, I don't like to do remote management. I don't want to learn PowerShell. And my advice to you is, the next time that happens, take a look at that person and ask yourself the following question. Is that person really worth 20 times the increase in size? Is that person really worth 4 times as many reboots? Is that person really worth 10 times as many security fixes? The answer may be yes. All right. Okay. No, this is yours.
Yes. Windows Server, our Nano Server and Windows Server V Next. So it is an installation option, much like Server Core. However, it's not going to appear in setup because it does require you to customize the image for your particular hardware. One of the reasons it's so small is we don't have all the drivers in there. There's no user mode plug and play. So what you have to do is you have to specialize it with the drivers you need, as well as which roles you want to install on it. So if you download the technical preview 2 that was released Monday morning, if you download the ISO, you'll see on there's a Nano Server folder. In there's a Nano Server WIM and a set of packages that you can install on it, as well as a README that links off to our guide on TechNet on how to work with Nano Server, how to get remote management set up, how to deploy it. I'll talk a little bit about some of that. So installing drivers for the leanest image, you want to figure out which drivers are required by your hardware and put only those in the image. That will give you the smallest image, and you use dism/add driver to inject those drivers. So all you need is a driver int file. Now, to make it easy, if you want to just get going quickly, we have created what we're referring to as the Nano Server OEM drivers package. So in that packages folder, you'll find that out there. And that's basically all the drivers that ship in box that are applicable on Server Core. So you could drop that big package in and just start up and get going with that to do some of your testing and perf analysis and things. Now, to run Nano Server in a virtual machine, there's a separate package you have to install. There's a set of guest drivers. So we don't have the virtual machine guest extensions installed by default. Back to what I was saying earlier, if you want just a Nano Server Hyper-V machine, you don't need those guest services, those guest drivers installed on that Hyper-V host or your file server host. So why have them installed by default? So that's another package that if you want to run in a virtual machine, you need to make sure you include that for networking and everything to work properly. Now, installing roles and features, as I mentioned earlier, they're separated out. So there's a packages folder, and you can see here the compute package is Hyper-V. The failover cluster package is pretty self-explanatory. The guest package are the guest VM drivers, OEM drivers. Storage package is your scale-out file server, and then that reverse forwarders package that I talked about. And so over time, as we add more roles and capabilities to Nano Server, you'll see more things showing up in the packages subfolder. And to install your packages, you, again, use dism add package. And you do have to install both the package as well as the language version of it so that your event log entries and things for that particular role or feature are in the appropriate language. Currently, the server bits are English only, so there's only the EN US folder. But over time, as we get closer to release, we'll start releasing localized builds, and so more subfolders will show up there. I'm installing agents and tools on Nano Server. I'm sure a lot of you are wondering, how do I put my particular management agent on my Nano Server machine? Well, there is no MSI support in Nano Server. That has a lot of dependencies, drags in a lot of additional functionality that would increase the size of the Nano Server image. So with today's builds, you have to do Xcopy deployments or use a custom PowerShell script to do all the registration and things you might need, creating registry entries. We are working on an installer that will be available for third parties to use to install their drivers and agents and other things onto Nano Server, as well as third-party apps and stuff can take advantage of this as well. And it will cover the common tasks that you might need from an installer. So install, uninstall, being able to inventory, and we will support offline and online installation. So you could take that Nano Server image, put your drivers in, put your role in, put in any agents, and have a fully set up and configured image that you then deploy to your hardware. On the side of deploying Nano Server, if you go in that Nano Server folder on the media, you'll see a Nano Server WIM. There is a commandlet or script you can download from the script center, convert Windows image. So if you want to just stand up Nano Server initially in a virtual machine and get going quickly with it and experiment with it, you can use that to convert the WIM into a VHD and load that up on one of your Hyper-V machines. And you can also use dism apply image to apply the WIM onto your physical machines. So a lot of what we've been doing, because we get daily builds of Nano Server, we've been using boot from VHD because we can just generate a VHD and copy that onto the system, have the latest and greatest machine up and running very quickly.
Great. So let's talk about the roadmap. So we've talked about the Nano Server, and this first iteration is focused in on two scenarios. Born in the cloud applications and cloud OS infrastructure. But that's really the beginning. Going forward, Nano Server is going to be the nucleus of all of Windows servers, okay? So we're going to target, so basically the idea will be, we'll refactor everything. Look, if you need 5 gigabytes to get your job done, you need 5 gigabytes worth of components, you should have 5 gigabytes worth of components, but not 10. If you want 500 megabytes of components to get your job done, you should have 500 megabytes of components to get your job done, not 10 gigabytes, okay? So it's really a beginning of a dramatic refactoring of the OS where you have just the components you need to succeed with your task at hand and nothing else. That's where we're going. So to begin with, we got Nano Server and born in the cloud applications. Not everything is going to run on Nano Server, so we have Server Core, again we'll call that Server, for your existing enterprise applications. And these things will again run in physical, virtual, or in containers. Now, the actions are to shift your management and tools to full remote management. You can do that today. You should definitely get on that page. This is the future. If you're stuck in a world of using RDS to talk to the local machines, you want to get out of that habit. It's a bad habit. Remember, it's heroin. Heroin's bad. Don't do heroin. Okay. Next, as you do that, you're going to have issues, or you may have issues. Please let us know about those issues, and we'll get those resolved for you. And then deploy Nano Server, get your apps and your tools on that. We got some feedback pointers here, and remote management feedback. Now, before you go, let me just be clear. This has been a very long, very hard effort. I mean, just an incredible amount of engineering. And I'd like Philippe to stand up. This is the guy who's been doing so much of it, Philippe and his team, and I'd like you to give him a great hand.
I think Alan's out there somewhere.
Say again?
I think Alan's out here somewhere.
Is Alan here? Oh, a superstar Alan back as well. Alan, please stand up. I cannot overstate how much hard work it was in the guts. You know, there's not a lot of glory down there refactoring code, and it would not be possible. These are dramatic results, and it would not be possible without their hard work. So we all owe them a great debt of gratitude. So lots more to go learn. We do pay attention to your feedback, and so please fill out the evaluation forms. And have a great MS Ignite, and thank you for your time.
Thank you.